The truth behind the return to the moon hides technical contradictions that NASA rarely admits publicly, revealing that the most powerful rocket in history may also be its biggest mistake. Many believe that the SLS is the pinnacle of modern engineering, but the reality is that it was built using recycled parts from old space shuttles, such as the RS-25 engines and fuel tanks. This design decision, while presented as a smart cost-saving measure, has generated an astronomical development cost that already exceeds tens of billions of dollars, raising questions about the long-term sustainability of the program. As the Orion capsule traverses the vacuum, experts debate whether we are witnessing a glorified museum piece or a true leap into the future for humanity. The urgency driving this mission is surrounded by an uncomfortable silence in the corridors of space agencies, where the multi-billion-dollar budget faces constant political pressure to justify every kilometer traveled. The design of the SLS, standing 98 meters tall, is frequently criticized for being a disposable system, where each launch consumes billions of dollars that will never return to Earth. This financial fragility puts the entire lunar exploration timeline at risk, transforming Reed, Victor, Christina, and Jeremy's journey into a test of institutional survival. The glitz of the launch masks the fact that every critical component of the rocket is destroyed after use, turning cutting-edge technology into expensive space junk. Unlike new trends in the aerospace industry that focus on the complete reuse of components, NASA opted for a model where the core stage and powerful engines are discarded into the ocean after only a few minutes of operation. This planned waste is one of the biggest criticisms from industry enthusiasts, who question why taxpayers should pay the price of a new rocket for each mission when more efficient alternatives exist on the private market. The SLS structure was assembled by engineers from every U.S. state, but this geographical distribution, while politically secure, makes the manufacturing and transportation logistics a bureaucratic and financial nightmare. While the crew grapples with isolation in deep space, a question from the public echoes loudly. How does the capsule maintain a stable internal temperature under such extreme conditions? Orion faces a brutal thermal challenge, where one side receives the scorching heat of the sun without atmospheric protection, while the other is facing the absolute zero of space. To manage these extremes, the European service module must work incessantly, circulating coolant fluids and adjusting the spacecraft's orientation to prevent the hardware from freezing or melting. If this thermal control system fails for even a few minutes, the integrity of the mission and the lives of the 4 astronauts would be irreversibly compromised in the middle of nowhere. But the real danger lies not only in the temperature, but in the fact that we are sending humans to the most isolated place in the universe, in a rocket that many consider obsolete. The decision to use solid fuel propulsion in the side boosters, decorated with the commemorative logo for the 250th anniversary of the United States, brings with it inherent risks that cannot be ignored during ignition. Once ignited, these boosters cannot be shut down, meaning that any anomaly in the first 2 minutes of flight requires an immediate and dangerous ejection of the crew through the escape system. This lack of complete control over initial propulsion casts a shadow over the safety of Orion, forcing the crew to blindly trust a technology that has already caused tragedies in the past. This reliance on legacy systems raises questions about NASA's actual ability to maintain a permanent base on the moon without the costs destroying the project. The budget required to maintain the SLS, Orion, and the future Lunar Gateway Station is so massive that many experts believe current plans will be drastically altered to avoid complete financial collapse. Political pressure to maintain contracts with large aerospace companies often clashes with the need for rapid innovation, creating a scenario where scientific progress is slowed by government interests. The technical reality is that despite all the hype, the mission is still an extremely risky test flight, where any error in life support or navigation could turn glory into historic disaster. What few people realize is that the greatest risk is not in the journey there, but in what happens if the main engine fails after the start of the lunar trajectory. If the upper stage engine suffers a critical failure after the translunar injection burn, the astronauts could be trapped in a trajectory that would take them far from Earth without enough fuel to return. This nightmare scenario is what keeps the control teams in Houston on high alert every second of the journey. The possibility of an eternal orbit without rescue is the variable that no one likes to discuss openly, but which dictates every technical decision made aboard the capsule. The intelligence of the flight plan depends on a free return maneuver that serves as the last lifeline for the 4 explorers. To mitigate the risk of a total propulsion failure, the trajectory was designed so that the moon's gravity would pull Orion back home naturally, even if the engines stopped working. This safety strategy is what allows the mission to proceed with an acceptable level of risk, validating the spacecraft's resilience in a crewed flight without exposing the crew to the even greater danger of an immediate descent to the lunar surface. It's the perfect balance between the ambition to explore and the pragmatic need to bring everyone back alive for the splashdown in the sea. Given all these technical risks and billion-dollar costs, would you dare to embark on a 10-day journey into deep space knowing there's no guarantee of return? Your participation in the comments helps build our community of enthusiasts and helps us understand if the risk is worth the scientific reward. The discussion about the cost and safety of the space program is essential to ensure that humanity not only returns to the moon, but remains there sustainably and transparently. Public engagement forces agencies to be clearer about the challenges faced, transforming each spectator into a watchdog of this new space race. The future depends on our ability to question the present so that the mistakes of the past are not repeated on the lunar surface. Despite the criticism and design flaws, the success of this stage is the only way for the next generation of humans to finally walk in another world. The lessons learned from the contradictions of the A.S.T.R.A.S and Orion missions will serve as a foundation for more efficient technologies that will eventually take humans to Mars. We are living in a moment where science fiction clashes with economic reality, and the result of this impact will define our history for the next 100 years. The technology we are evaluating today, however expensive and controversial it may be, is the necessary stepping stone for the moon to cease being a destination for short visits and become our first outpost in the cosmos. But if the ultimate goal is to establish a permanent presence, one troubling question remains that NASA has yet to definitively answer. Why not land now? The answer to this simple question reveals the greatest contradiction and the secret that will be explored in the final phase of this investigation. The reason they are only orbiting the satellite at this moment hides technological and strategic limitations that could completely change your perception of what we are really doing up there. Get ready, because the final piece of the puzzle is about to be revealed, and it may be more surprising than the launch itself.